Hello, everyone, and welcome to H&M Technologies online training program. In this session, we are going to understand the supervised learning algorithms. Supervised learning is the most commonly used type of machine learning. In this method, the model is trained using labeled data. This means we already know the correct answers for the training dataset. The model learns the relationship between input variables and output labels. Once trained, it can predict outcomes for new, unseen data. Supervised learning is widely used in industries for making accurate predictions. Supervised learning is divided into two main types: classification and regression. Classification predicts discrete categories such as pass or fail, spam or not spam. Regression predicts continuous numerical values such as salary, temperature, or house prices. Understanding the difference between classification and regression is essential when choosing an algorithm. Linear regression is one of the simplest supervised learning algorithms. It is mainly used for regression problems where we predict numerical values. The algorithm finds the best-fitting straight line that represents the relationship between input and output. For example, predicting house prices based on area. It is simple, fast, and easy to interpret. Logistic regression is used for classification problems. Despite its name, it is not used for regression tasks. It predicts the probability that a given input belongs to a certain class. The output is usually binary, such as 0 or 1. For example, predicting whether an email is spam or not. A decision tree is a tree-like structure where each node represents a decision. It splits data based on certain conditions. For example, if marks are greater than 50, predict pass, otherwise fail. Decision trees are easy to interpret and visualize. They can be used for both classification and regression tasks. K-nearest neighbors is a simple supervised algorithm. It classifies a new data point based on the majority class among its nearest neighbors. The value of K determines how many neighbors are considered. It uses distance metrics like Euclidean distance. Although simple, it can be slow for large data sets. Support vector machine, or SVM, is a powerful supervised algorithm. It finds the optimal boundary that separates different classes. The goal is to maximize the margin between classes. SVM works well in high-dimensional spaces and is widely used in image and text classification. After training a model, we must evaluate its performance. Accuracy measures overall correctness. Precision measures how many predicted positives are actually correct. Recall measures how many actual positives were correctly identified. F1 score balances precision and recall. Choosing the right metric depends on the problem type. Overfitting occurs when the model learns the training data too well, including noise. It performs well on training data, but poorly on new data. Underfitting occurs when the model is too simple and cannot capture patterns. The goal is to find a balance between bias and variance. Proper validation helps avoid these issues. In this session, we learned about supervised learning and its main types. We explored important algorithms including linear regression, logistic regression, decision trees, KNN, and SVM. We also discussed evaluation metrics and overfitting. These algorithms form the foundation of practical machine learning applications.